This is TMUA 2021, Paper 1, Question 18. We're given the function x equals y squared minus 6y plus 11. The graph of this is rotated 90 degrees clockwise about the point minus 2, 3. And we want to work out the equation of the new curve, which we'll call C. So how might we sketch this first, the original curve? Well, you see this is a quadratic in y. So remember when you're sketching quadratics in x, to sketch it we often worked out the roots and the turning points, and we often did that by completing the square. So we do the same thing here, and we'll complete the square in y. This gives us exactly y minus 3 all squared minus 9 plus 11, which gives us 9 minus 3 squared plus 2. So how does this graph look like? Well, because this is a positive quadratic in y, this point here, when y is equal to 3, this would give us the minimum value of y. So this would be a quadratic of this shape, as this would be the closest point to the y-axis. And then because this is the minimum, this occurs at y value 3, and its x value is 2. So it's like sketching a quadratic in x, but it's flipped around. So now we're going to rotate this about the point minus 2, 3. So I plot that point here. This is our centre of our rotation. So when we rotate 90 degrees clockwise, it's going to send this point over somewhere over here. So where would this new graph look like? It's going to look like this, but when it's rotated, it's going to look something like an N shape. But when you rotate something, the distance from its centre, the centre of rotation, remains constant. So where will this new vertex be? Well, because the distance here is 4, this is going to get sent to somewhere over here. Is also going to be 4 units vertically below the centre of our rotation. So it's going to look something like this. So the x-coordinate of our vertex is going to be at minus 2, and the y-coordinate is going to be minus 1, because this was 4 away from minus 2, the x-coordinates here. So this is going to be 4 units vertically below our centre. And if this was at 3, this would be at minus 1. So now what would the equation of our curve look like? Well, this is going to be some sort of quadratic in x, and it's got a vertex at minus 2 and minus 1. So plugging that in gives us that by reversing the complete to the square form, y must be of this form. So expanding gives us this, and simplifying it down gives us that y is equal to minus x squared minus 4x minus 5. So the answer is B.